Before we get into the full process of finding critical points and completing the second derivative test, we want to look at just interpreting the value d that we'll get from this process. That is f sub xx times f sub yy minus f sub xy times f sub yx. Each of those second derivatives of the original function evaluated at each critical point, and see what that tells us about the point that we've identified. In example 1, we see that a function f has a critical point at -8, -3, and we're given the values of those second derivative functions evaluated at these different points. That means in example 1, to calculate d, we would take 9 times -6 minus -7 times 3, which would give us a value of -33. In this case, our value for d is less than 0. We have a negative result, which tells us that -8, -3 is a saddle point. Meaning that critical value is neither a maximum, a local maximum, nor a local minimum. In example 2, we do the same process, but now we have different values for our second derivative function evaluated at this new critical point. We'll still take the result of each of those second derivative functions and take -4 times -3 and subtract 6 times 0 to get 6. In this case, our value for d is positive, greater than 0. And we can see that g sub xx, that first derivative with respect to x, and the second derivative with respect to x, evaluated our critical value is equal to -4, which is less than 0, which tells us that 7, -9 is a local maximum. Since d is positive, but g sub xx evaluated the critical value as negative, we have a local maximum. In example 3, we'll evaluate d again by taking 3 times 9 minus -4 times -3, which will give us 15. So our value for d is, again, positive, greater than 0, and t sub xx, which is equal to 3, is also positive, also greater than 0, which tells us that 4, -7 is a local minimum. In example 4, we'll calculate d again, which will be 5 times 3 minus 15 times 1, or 0. Since we get d is exactly equal to 0, that tells us that the test is inconclusive. Which is, again, a different result than what we saw in example 1. In example 1, d was less than 0. That tells us that the critical point is neither a maximum nor a minimum, but a saddle point. In example 4, d is exactly equal to 0, which means the test is inconclusive. There is literally nothing we can say about this critical value without doing some more work that's not within the scope of this class.